From a LAN architecture perspective, we have the infamous three-tier campus network design. And what we have in this architecture is we got these access layer switches that have the PCs plugged in, laptops. We could have servers plugged in here, different devices. We could also have a voice over IP phone plugged in to the switch directly. So these are the end devices here at the access layer that need to be connected to the network. Taking a step back here, a switch is a very important device when it comes to building a network. That's one of the most fundamental components you need to start building a network. And access layer provides access to the different endpoints. So we got endpoints that are connected to the access layer switches. What ends up happening next is that we have distribution layer switches. And in distribution layer, these are basically aggregation switches that are taking a bunch of connections from the access layer switches and combining them into a distribution layer, also called aggregation layer. And here, the idea is that we got all these different connections coming from the endpoints. It becomes a point of consolidation. It handles all the different links that are coming from the access layer switches. And in particular, we call these links that are going up and getting plugged into the distribution layer switches from the access layer, uplinks. They're very conveniently named uplinks. All the links that are facing the clients and the endpoints, these are called downlinks. Okay, so this is an important terminology to understand. When somebody says, where's the problem? Downlink or an uplink? Immediately you should get this picture in your head as you're troubleshooting. A picture where you understand that the downlink means the ports that are facing the endpoints, and the uplinks mean interfaces that are facing the switches upstream. And finally, we have a core layer. And the whole reason we have a core layer in our network is to consolidate a bunch of distribution layer switches. So this comes into play. This type of model, a three-tier campus model, is suited for large enterprises. You're looking at Fortune 500 companies, possibly up to Fortune 5,000. But these are gigantic, large corporations with a ton of locations. And what you end up doing is you take a bunch of different buildings and you consolidate them together and interconnect them together. And core layer is what connects those different buildings together. So for example, in building one, you'll have distribution layer switches in building one. And then you have building two, that has its own distribution layer. Then you have building three, that has its own distribution layer switches. Building four, same thing, and so on and so forth. Well, how do you connect all of these distribution layer switches together? One way would be to actually interconnect them all in a full mesh, and full mesh gets really, really ugly really quickly. You wouldn't want to do that. Instead, what you do is you have these distribution layer switches, and we end up using one of the buildings as the primary building. So let's say building one might become the core of our network. And this is where we would install core switches, and all of the distribution switches from different buildings would physically run their cables and get plugged into the core into building one. And that's why we need this three-tier hierarchical architecture. And another reason we need hierarchy is because it's easier to troubleshoot, it's easier to design our network, plus it's easier to make purchasing decisions. When you're looking at buying access layer switches versus distribution layer switches or core layer switches, each layer serves a different purpose. So it makes your choice as an end user a lot easier to decide how to plug different switches into each layer. So it makes it like a Lego block type approach where you just fit the different blocks into the different layers. Hope you enjoyed today's video. If you did, give me a thumbs up, hit subscribe, and I'll see you in the next video.